Let's take a look at quadratic equations. Now, the first property we want to look at is called the zero factor property. Different books call this by different names. Zero product principle, zero product property. I like zero factor property the best. It says if you got something times something else equal to 0, then you can set each factor equal to 0. So we set p equal to 0, and we set q equal to 0 in this case. Now that's pretty vague what I just said. If you got something times something else equal to 0, it really is meant to be that vague. It doesn't matter what it is. Now in terms of quadratics, we'll have like a binomial times a binomial. But it says simply that, something times something else, and you can set each factor equal to 0. Take a look at our first problem here. We got x squared minus 7x minus 30 equal to 0. And solve each equation by factoring. Well, first thing, the name tells us exactly what to do. 0. Get 0 on one side. Well, we have 0 on one side. Then it says factor, so we're going to factor the other side. Well, this is the PST method. We got x squared, x, no number in front of the x squared. That's what tells us PST. So we take the number at the end, the 30, ignore the sign, and we're going to come up with 3 columns. The P column, P stands for product. We'll write all the products to give us 30. We got 1 times 30, 2 times 15, 3 times 10, 5 times 6. The S stands for sum. We're going to add these together. 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 is 11. The D stands for difference. We'll subtract smaller from larger. 30 minus 1 is 29. 15 minus 2 is 13. 10 minus 3 is 7. 6 minus 5 is 1. Number we're looking for is a number in our middle term, which is a 7, which is right here, which means we use 3 and 10. So we got x, 3, x, and 10. Now our larger number in the P column that we're using 3 and 10, so our larger one we're using is 10. We'll always have the same sign as the middle term. Well, middle term's a negative, so this would be a negative. Now the number I circled is in the difference column, D for different signs. So if that one's negative, then this one will be positive. If you want to see more of this technique, you can go watch the video. There's a separate video on factoring using the PST. Now zero factor property. We got 0 on one side, we factored the other side. So it says set each factor equal to 0. So I'll set x plus 3 equal to 0 and x minus 10 equal to 0. And then solve these. Take the 3 over and we get x is equal to negative 3. Take the negative 10 over and we get x is equal to positive 10. And those are our answers. Let's take a look at another one. Well, I guess I'll put it right under here. Okay, we got 9x squared minus 28x is equal to negative 3. Well, to begin with, this zero factor property, you have to have 0 on one side. So I notice first thing I have to do is take that negative 3 and move it to the left side. Now if you move anything across your equals, your sign changes, so negative 3 becomes a positive 3. And on this one, we'll factor it using the key number method. Why the key number method? Well, we have x squared, x, no x, and there's a number in front of our x squared. That tells us the key number method. Now we're going to take the number at the beginning times the number at the end, ignoring signs. So I take 9 times 3, and that gives us 27. We're going to create our 3 columns, P, S, and D again. We're going to do something a little bit different with them, though. P, we're going to list all products give us 27. We got 1 times 27, 3 times 9. I think that's it. Now the S column, we want to add these together. 1 plus 27 is 28. 3 plus 9 is 12. In the difference column, we want to subtract them. 27 minus 1 is 26. 9 minus 3 is 6. Now, a number we're looking for is a number in our middle term, which is 28, which is right here, which means we use 1 and 27. Now, with the key number, what we're going to do is we're going to rewrite our middle term using those two numbers. Now, the larger number in the P column that we're going to use, we're using 1 and 27. The larger one is 27. Will always be the same sign as the middle term. Middle term is negative in this problem, so we got negative 27x. The number we circled is in the S column. S for same signs. So if 27 is negative, then the 1 will be negative. Now we want to use factoring by grouping. Group the first two terms together, they have a 9x in common. And that gives us x minus 3. The last group doesn't have anything in common, but the first term is negative, so I'll factor out a negative 1. And that leaves us x minus 3. Now our goal was to get this parentheses the same as this one, and it is. So I can factor the x minus 3 out in front. Now to decide what goes in your second set of parentheses, you cross out the x minus 3's, and then this gives us 9x minus 1. Okay, zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 3 equal to 0, and 9x minus 1 equal to 0. Take negative 3 over, it becomes a positive 3, so we get x equals 3. On this one, take the negative 1 over, it becomes a positive 1. Then divide both sides by 9. And we get x is equal to 1/9. Now, if you're weak on factoring, you probably want to go watch the factoring videos to kind of refresh your memory on that. If you're good at factoring, this property is very, very straightforward. Now, the next problem is you're going to use a square root property. Besides it telling us to use a square root property, let's take a look at a form of one. Of course, it says use it. But we got 5x squared minus 1 equals 44. And you're sitting there, well, that doesn't seem a whole lot different than this. Notice what we have here. We have 28x. We have the x component, the x term. There is no x here. Look at this one. We have all this squared. So that's what makes this different. That's what tells us to use a square root property. Square root property says if you can rewrite it as something squared equal to something else, boy, talk about vague. Square root property says drop your squared, put a plus or minus square root on the other side. It really is as vague as I just said. As long as you got something squared equal to something else. And drop your squared, put a plus or minus square root on the other side. Let's take a look at this one. We got 5x squared minus 1 equals 44. Now, for us to use this property, the entire left side has to be squared, or entire right side, as the case may be. But the entire left side isn't squared, just the x's. So let's work at getting it by itself. I'll take negative 1 over the other side. So we got 5x squared is equal to 44 plus 1. Remember, when you take anything across equals, the sign changes. 44 plus 1 is 45. Now the entire left side is still not squared, just the x's, not the 5. So I want to divide both sides by 5. When I do that, those 5's are going to cancel. And we got x squared is equal to 45 divided by 5 gives us 9. Now the entire left side is squared, which is what this property says. So we got the entire left side squared. We'll drop our squared, and we'll put a plus or minus square root on the other side. You always want to simplify a radical if you can. 9 is 3 times 3. This is a square root, which means looking for a pair of somethings. So here's a pair of 3's. A pair of 3's is going to come out in front as a single 3. So we got x is equal to plus or minus 3. And that's our answer. Let's look at another one. You got x minus 5 squared is equal to negative 16. Well, it's already in the perfect form. The entire left side is squared, isn't it? Well, our formula says drop a squared, and you put a plus or minus square root on the other side. So we've got x minus 5 is equal to plus or minus negative 16. We got negative 1 times 4 times 4. Now we want a pair of something. Here's a pair of 4s. So a pair of 4 is going to come out in front as a single 4. And this negative 1 will come out as an I. So we get 4i. Remember, whenever you have a negative 1 inside of a square root, it'll always come out as I. Now, since everything disappeared out of our radical, the radical just drops away. Now, we're still solving for x, so I'm going to take the negative 5 over, and we got x is equal to 5 plus or minus 4i. Let's take a look at this one. Got 9x minus 2 squared is equal to 25. Again, it's already in perfect form. The entire left side is squared. So our property says we drop our squared, put a plus or minus square root on the other side. Always you should simplify your radicals any step if you can. 25 is 5 times 5. The square root, again, we're looking for a pair of somethings. Well, here's a pair of 5s. So a pair of 5 is going to come out in front as a single 5. So we got 9x minus 2 is equal to plus or minus 5. Now, nothing's left inside the radical, so we just drop it. I'm going to take that negative 2, move it over, so we get 2 plus or minus 5. Trying to get the x by itself, so we're going to divide both sides by 9. And do that, those 9's going to cancel. And we got x is equal to 2 plus or minus 5 over 9. Now, if your radical disappears completely, it's probably a good idea for you to split them up into two separate pieces. What that plus or minus means is it means we got x is equal to 2 plus 5 over 9, and we got x is equal to 2 minus 5 over 9. 2 plus 5 is 7, so we got 7/9. 2 minus 5 is negative 3, so we got negative 3/9, which reduces to negative 1/3. And those are our answers. Let me take a look at one more of those. So we got 3x plus 5 squared is equal to 12. Well, again, the entire left side squared, so it's perfect form for that. And that's a key. When can you use this? Well, when you can get the entire left side squared easily. Well, property says we drop our squared, and we put a plus or minus square root on the other side. Well, 12 looks like something I can simplify. If I did the prime factorization factor tree, we got 2 times 6. 2's prime, so we circle it. 6 is 2 times 3. Both of those are primes, so we circle it. So we're going to rewrite 12 as 2 times 2 times 3. Now I want to simplify that radical. And it's a square root, so we need a pair of somethings. Here's a pair of 2's, so they're going to come out in front as a single 2. So we got 3x plus 5 is equal to plus or minus 2 square root of 3. Now we're trying to get the x by itself, so I'll take that 5 and move it over the right side. So we got 3x is equal to negative 5 plus or minus 2 square root of 3. And then we're going to divide both sides by 3. Because again, we're trying to get the x by itself. When I do that, those 3's going to cancel. And we got x is equal to negative 5 plus or minus 2 square root of 3 over 3. There's no need to break this into two separate pieces because the radical didn't disappear. If that square root had disappeared, then we would have broken it apart. Let me scroll down a little bit. Now the next item we're going to take a look at is the quadratic formula. We looked at the zero factor property. That works well if it can factor. We looked at the square root property. That works well if you can get the entire left side squared easily. But let's say you can't do either one of those. And you got something to the form ax squared plus bx plus c is equal to 0. Have to have 0 on the right side. A and B and C represent numbers. Whatever numbers, A is whatever numbers in front of your x squared, B is whatever numbers in front of your x, and C is the number at the end. If you got it in that form, then the quadratic formula says x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So let's take a look at the problem dealing with that. We've got 21 x squared plus x minus 2 equal to 0. Now it says solve it using quadratic formula. We might try to factor it first, see if it factors. It might, I don't know. But let's go ahead and use quadratic formula since that's what it says. Now first thing we need to do is identify, well first notice is zeros on this side, so that's okay. First thing we got to do is identify our a, b, and c. A is whatever number's in front of your x squared, which is 21. B is whatever number's in front of your x, which is invisible 1. And c is your number at the end, which is negative 2. Now I'm going to go through this formula here and replace my variables with parentheses. Everything else is going to remain as is. This helps reduce sign errors if you do this. So a negative is there, the plus or minus, square root, the second power, the minus 4, the 2 down here. Just replace the variables with parentheses. Now where our b was, we'll put in 1. Where our a was, we'll put in 21. And where our c was, we'll put in negative 2. So we got negative 1 plus or minus. 1 squared is 1. Negative 4 times negative 2 is positive 8 times 21 is 168. All over 2 times 21 gives us 42. Which gives us negative 1 plus or minus square root of 169 over 42. 169, that's 13 times 13 over 42. Now remember, the square root, we're looking for a pair of somethings. Here's a pair of 13s. They're going to come out in front as a single 13. So we've got negative 1 plus or minus 13 over 42. Now notice here, our radical disappeared, didn't it? Again, that's a good sign of when should you split it apart. What that plus or minus means is we got negative 1 plus 13 over 42. And we got negative 1 minus 13 over 42. Negative 1 plus 13 gives us 12 over 42. Negative 1, negative 13 gives us negative 14 over 42. Now 12 and 42 are both divisible by 6. That gives us 2/7. Now over here, these are both divisible by 7. They're actually both divisible by 14, but that's kind of hard to see, actually. Let's start with the 7, and then it'll be obvious. Negative 14 divided by 7 is negative 2. 42 divided by 7 is 6. And I see negative 2, 6. They're both divisible by 2. So that gives us negative 1/3. I only know that. Normally I wouldn't have caught that, except for I screwed it up in class. I didn't see they were both divisible by 14. I just divided both of them by 7, and then realized, oh, they can break down more. But those are our answers. Okay, let's look at another one. Different variable, but same idea. We got 7w squared is equal to negative 2w plus 3. Now we can't use the quadratic formula yet because we don't have 0 on one side. Well, that's easy. I'll take negative 2w over to the left side, and I'll take the 3 over the left side. Take anything across your equals, your sign changes, so the negative 2w becomes a positive 2w. The positive 3 becomes a negative 3. Now we got 0 on this side, so we can use quadratic formula. A is going to be whatever number is in front of our w squared, which is 7. B is whatever number is in front of our w, which is 2. And C is our number at the end, which is negative 3. Our quadratic formula is negative b plus or minus square root. It's not x, though. It's w in this case. Okay, w is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. It's a good idea to go through and put parentheses in for your variables before you plug in your numbers. Once you get comfortable with it, sometimes you won't do that, but it does help reduce sign errors. Now everything else remained the same, the negative, the plus or minus, square root, second power, negative 4, all that. So where our b was, we'll put in 2. Where our a was, we'll put in 7. Where our c was, we'll put in negative 3. Well, that gives us negative 2 plus or minus. 2 squared is 4. Negative 4 times negative 3 is 12. Times 7 is 84. So that's plus 84. Over 2 times 7 is 14. Let me check that. 12 times that. Yeah, that gives us that. Which gives us negative 2 plus or minus. 4 plus 84 is 88 over 14. Now, 88 looks like something we can break down. Don't hardly have room here, but 88 is 2 times 44, 2's prime, so we circle it. 44 is 2 times 22, 2's prime, so we circle it. And 22 is 2 times 11. Both those are prime, so we circle it. So 88 breaks down this way. We've got 3 2's, 1 11, all over 14. Now, square root, we're looking for a pair of somethings. Here's a pair of 2's. So a pair of 2's is going to come out in front as a single 2. So we've got negative 2 plus or minus 2 square root 2 times 11 is 22 over 14. They should call this the 3-number rule. But if you can divide this number, and this number by the same number, do so. Well, they're all divisible by 2. So we got minus 1 plus or minus 1 square root of 22 over 14 divided by 2 is 7. So again, negative 2 divided by 2 is negative 1, 2 divided by 2 is 1, 14 divided by 2 is 7. So then our answer is negative 1 plus or minus square root of 22 over 7. Try it again. 22 came out kind of weird. There we go. That's our answer. Let's take a look one more. We got 3x squared minus 5x plus 9 equal to 0. Well, we have 0 on one side, so it's in perfect form to use the quadratic formula. A is going to be whatever's before x squared, which is 3. B is going to be our number before x, which is negative 5. And C is going to be our number at the end, which is 9. We've got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Probably a good idea to go through and put parentheses in for your variables before you plug in your numbers. Everything else remains exactly the same. I'm just replacing the variables with parentheses. Okay, now where our b was, we'll put in negative 5. So I got negative 5, negative 5. Where a was, we'll put in 3. So 3, 3. And where a c was, we'll put in 9. Negative, negative gives us a positive. So we've got 5 plus or minus. Negative 5 squared is 25. Negative 4 times 3 is negative 12 times 9 gives us negative 108, assuming I multiplied everything correctly, over 6. Okay. Okay, so that gives us 5 plus or minus 25 minus 108 is negative 83 over 6. Let me double check that. Yeah. Okay. Now we want to simplify the radical. 83, I don't think we can break down any, but notice we got a negative. That negative comes out as an I. Remember, whenever you have a negative inside of a square root, it gives you an imaginary proportion. And typically we want to write those as separate pieces. So we put the 5 over 6 plus or minus square root of 83 over 6 with an I to the side. And that's our answer.